You don't have to do that right now, but I'll show you later why it's sometimes useful to have this info. And essentially, it's the tables that's telling you how highway capacity manual defines level of service letter for signalized and unsignalized intersections based on the average vehicle control delay. So it's a little different whether it's a signalized or an unsignalized, right? So I'll come back to that after when we're done with the Excel. So if everybody can you can either watch or you can follow along and do it while I do it. Depends how quick you are. That's fine. For AM node, so what we're going to do is we're going to manipulate this spreadsheet because what we want to do is calculate the average delay for each movement, right? And essentially what the spreadsheet, so what Vissim, how Vissim has grouped everything together is you can see here we have our, one second, let me scroll down. So we have the first column are the runs, right? So this is actually called, if I open this up, sim run. And so we can see simulation run 1, and then it works all the way down 2, 3, 4, 5, 6, 7, 8, 9, 10. And then it does average, standard deviation, min, and max. And then within each run, so run 1, it's broken it down by time intervals. And then so you can see the first interval is the 300 second to 600 second interval. Sorry, do you mind if you just mute your thing? I'm getting an echo. I can't even hear. Okay, thank you. And then for within each interval, it then breaks it down by intersection. So you can see each group this is a node. So you see node, just the way mine are numbered. It could be different than how yours are numbered, but mine are numbered node 3, node 4, node 5. So you can see the first number is the node number, node 6, 7, 8, 9. And then that's it for the 300 to 600 second interval. And now we go into 600 to 900 second interval and we start again, node 3, node 4, et cetera, et cetera. And then you can see within each node, so node 3, it's broken down to individual movements. And how I kind of mentioned it in the last class, the way you read these movements is, for example, if I just pick one randomly, like this one, number 8 to number 13. So the number that just is before the @ symbol, that's the link or connector number. And the number that follows immediately after the @ symbol, it's basically a location on that link or connector. So it's really irrelevant to you. It doesn't matter. So really what you can care about is the two numbers before the @ symbol. So 8 and 13. So if I were to go to node 3 and look at movement 8 to 13 in my Vissim model, so this is node 9. Okay, maybe I started over here. One second. Node 8, node 7, node 6. 5, 4, that's my roundabout. So node 3 is my roundabout, and I'm looking at movement 8 to 13. So that is, so this is link, here's 8. So that's link 8 to 13 is probably this one. Nope, so that's link 5. That's 13 up here. So that means 8 to 13 is going from this lane through the roundabout to this lane. And it's important to think about this in this way is this is why we do nodes, because you can see that's a long movement, right? Like the vehicle is making a right turn here. There's potential for delay at this specific spot as he's awaiting for gaps in the roundabout. And then he enters the roundabout. But what if there's like a clog in the roundabout, or like what I mean clog, like it's fully congested because there's something going on somewhere else in the roundabout, that cars are backed up through the roundabout. Maybe he gets delayed right here and then he gets out. So there's, depending on the intersection type and configuration, there could be multiple points within the node that a vehicle may stop and slow down and experience some delay. And what's nice about this is looking at it kind of like looking at the big picture and saying, what's the total delay? It's not telling me what's the specific delay at this point and then at this point, and then at at another point, maybe up here, if there's pedestrians crossing and the vehicle stops and he's going to incur a second or two of delay here as well. It's not breaking it down. It's telling you what the total picture is, and that's what a traffic engineer for the 90% of the time wants to see. They want to know what delay is the driver going to have at this intersection, regardless of what movement he's making or how many movements he's making within the intersection. He just wants to know what's the total delay. So very simple. So that's what the benefit is of drawing these nodes. Yeah, so. And then for each movement, we have these different values. And I think I kind of went over this in the last class or 2 classes ago. The Q length, so Q length. So Q length is really the average Q length, because there is no one Q length, right? So if you think this value right here, 1.37, that's 1.37 meters, but you can see it's within an interval of 300 seconds, right? 300 to the 600th second. So the Q length is constantly changing within that time window. So this is the average Q length within that 300-second window. Then this is the maximum Q length within that window. This is the vehicles. This is the persons. So that those numbers, like persons, that comes into play when you're doing more complex evaluation, where we're looking at, a certain number of people per vehicles, and some vehicles have 1 person, some vehicles have 3 persons, and you can get more complex analysis. But right now, it's just defaulting to assuming 1 person per vehicle, right? So you just have 1 and 1.
Adam?
Yes.
What's the meaning that we have at that link 1 vehicle only?
Within that 300-second window, only 1 vehicle made that movement.
Okay.
So that's not your peak hour. That's not your hour volume. That's just within that one. That's how many vehicles were recorded in that 300 seconds, right? Making that movement. Level of service letter. So this is your LOS. This is your level of service value. So 1 second of average vehicle control delay. So 1 second. So it's approximately 1 second. It's my apologies. This is the seconds. It's 0.83. And then what Vissim does is it assigns it into a letter. So we all know that 0.83 seconds is equal to LOSA. So they put LOSA here, and then they assign LOSA a numerical value as well. So they just give it a 1. So if we have an LOSB, so you can see down here, it gives it a numerical value of 2. I'm not sure why. I think it's just help you with if somebody wants to analyze this spreadsheet with formulas. It makes it easier if you can assign numbers to the LOS letters. So like LOSC right here, they give it a number 3, right? So it's just LOS value. Here's the vehicle delay. So we all know about that. That's average vehicle control delay. Here's the person delay. So we're not really looking at persons in this model, so it just defaults to the same as the vehicle. Let me just open up these just so you can see it for the first time. I won't explain it to you again. Stop delay, stops all. So I'm not sure about the definition of stops. You can look this up in the manual if you want. It's just the number of stops. I don't know how it determines a stop. It must have to do with the speed. If your vehicle slows down to such a low speed, it will consider it a stop, right? And then we have some emissions and fuel consumption calculations, and the manual tells you how it calculates that. So this is very standard stuff. And I know, like, if you do synchro reports, usually you get a lot more information than this. So this isn't too crazy for you. So what I would do now is we want to calculate the average vehicle control delay. But what we need to do is average out all the intervals. So if you have a specific movement, we want to find what's the average delay within each 300-second interval for that run. And then we want to find out what's the average delay for all 10 runs, right? So it sounds like a little complicated, but let me just show you the process, and then I can have you guys try it out, or if you guys want to do it while I do it, I'll do it slowly. So first thing I would do for this, so you copy and paste your data in. I would delete this first row because it's pretty silly. I don't know why they do that. So you delete the first row, so that's not going to cause any problems when you sort your data. Then what I would also do is delete all the bottom rows of the table except for the average rows. So you'll see what I mean if I go down here all the way to the bottom. See how they did max. So I would highlight, so I would click on the row headers and drag up and highlight all the max, min, standard deviation, and then you're gonna slow down a little bit. And that's it. And then I'm gonna go down a little bit and just that. And then I'm gonna right click, delete, because we want to keep average because we're working with averages, right? So we want, it's already done a lot of the work for us by averaging up stuff. So I'm gonna go back to the top. So now we have all of our runs and then the average of the runs at the bottom. Next, let me just think. Let me just think there's different ways to do this. Yes, okay. So what I would do is, what we want to do is we want to make like a summary table at the bottom that kind of summarize the average delay for each movement. So what I would do if I were you is I'd go back up to the top. I would highlight all your movements in the first run. So we have, so node 3, node 4, node 5, node 6, 7, 8, 9, and that's it. So these are there. So that's all the movements in the network. And then they just repeat after that, right? So what I'm gonna do is I'm gonna copy this. I'm gonna go all the way, I should go faster. I'm gonna go all the way to the bottom. And I am going to paste it, say here. And then I'm also gonna bold it. And what we can do after is once we populate this table, because over here, we're gonna put in what the delays are next to each movement based on the calculations up above. But what you can also do is you can write, in here, for example, or like here. So say node 3 is, I know it's my roundabout. So right here, I might write, roundabout. And then node 4, whatever the intersection is, I don't know what it is, but street A at street B, for example. And that's how you just build your table. And then right here at the roundabout, you can do the movement names. So you would look in you would have maybe your model, your Vissim model on another screen and maybe your Excel spreadsheet on this screen. And you would find what movements these are. And then you would put in, similar to synchro, eastbound right, eastbound through, eastbound left, whatever it is, right? Northbound through, southbound right, whatever this movement is next to it. But you'll notice, yeah, I'll just leave it at that. We'll troubleshoot issues if you run into any. But that's what you could do, right? You could do that after. So I have all my movements listed here. Then what I would do, just to make your life simple, you don't have to do it. I would hide all the rows, not the top row, leave the top row, but I would hide all your rows except the average row. I wouldn't delete them in case you need to open it back up and look at something. If you find there's a number that comes out strange and you're like, huh, why do I have 5,000 meters of queue for this movement? So you may want to unhide all these rows and look at your individual runs to see what happened. So what I'm going to do is hide it all. So it's in there. But now I'm just looking at my averages, right? And this is what I want. So it's basically the average of for each movement. And then what you're going to do is calculate the average delay for each movement, right? So for example, so delay, vehicle delay is right here. This is your actual numbers for vehicle delay. So if you want, you can highlight that yellow, the whole row, just so you can, And what I would do if I were you, I'd go down here and right here. So for this movement, the vehicle delay is going to be equal to the average, and you are going to go and click through for each time interval for that movement. So you see this is the movement up here at the top. Okay, this is a bad example to do for the first one because it has no value, but you'll see what I'm talking about in a second. So that's this movement. So then I'm going to go down. It's that movement again. Here. I'll do this again. I'll help you guys out. Just give me 1 second. Wait, oh, too far. Of course, it's already covering that. That one. That one. Almost done. Then the last time interval is coming up. Now we're at 3,600. Right here. That's it. And now we're at our bottom. And then I close bracket. So there's obviously no values. That's why I'm getting an error, but that's okay. It doesn't matter because now I'm going to drag it down. Okay. So those are all our delays for all your movements. Like I said, you're going to see some movements that have these weird errors because depending on how the node is drawn, sometimes it'll identify some like bogus movements, like movements that aren't really a movement. It just happens to be where like one link kind of connects to another link and it kind of considers it a movement, but you really have no volumes doing that. So you'll pick up on it in a second. So yeah, no problem. So this is essentially it. And then what you can do is, like I said, is, I lost that table. I had that table. It's up hidden somewhere where I have the LOS letters. Oh, nice. They're right here. So I'm going to drag these. I'm going to copy, bring them down here. I've done it before where I just do a formula where it tells me what the LOS is based on what the delay is. But really, what you can do just for your own ease is you can kind of know if you know, so it's a roundabout, it's unsignalized, right? So you know if it's based on the table beside you, A is less than 10 seconds. It looks like a lot of my movements are less than 10 seconds, right? Actually, and if it's 0, I should put nothing.
Adam?
Yes.
These tables, you get it from which manual?
Okay, so you can Google it and find it. Let me just pull up. I'll send you guys actually a link where I got it. 1 second. Here, let me send it to you guys through Teams. Okay, so I just sent you a link. So that document at that link should have both of these tables, and it's just nice to take a screenshot and you can paste them into your Excel file. So essentially this is what you do. And then, like I said, if I were you, I would find out what these node numbers are. So this is node 3. I know it's my roundabout. So I'd write the name of my roundabout here. And then, number 4, I know, then you would look in your Vissim model, where's node 4? And there's different ways you can find node 4, right? Either you can just hover over individual nodes and see what number pops up, or you can go, show list with your nodes and double click on 4 and it should, node number, it's actually this row, it highlights, right, in your network. So that's node number 4 right there. So you may want to write the name of the intersection. It's up to you, right? And then for your individual movements, like I said, so node 4, so this is movement Also, oh, actually, this is great because I actually named it in my Vissim model, right? So I know it's Kaufman Drive. You can see at Bimbrook Road. And so this first one is Kaufman Drive to Bimbrook Road, but it's Drive to 4. 1 Kaufman Drive to 4 Bimbrook Road. So let's see what that means. So yeah, 1 Kaufman Drive. So you see that's link 1 Kaufman Drive to 4 Bimbrook Road right there. See link 4 Bimbrook Road. So that's northbound right. If it was northbound left, it would have been 1 Kaufman Drive to 6 Bimbrook Road. So I know 1 to 4 is northbound right. So right here, I would just do northbound right. And then I know here 1 to 6 is I know northbound left. And then 3, so this is 3 to 2. And this is what you guys are going to do, right? So 3 to 2, that's your westbound left. And again, it's a lot easier if you put your Vissim on one screen and then you have your spreadsheet on the other. And then this is 3 to 6. So that's going to be the westbound through. And then let me just do these last two. 5 to 2 and 5 to 4. That's 5 to 2 eastbound right, and then 5 to 4 is eastbound through. So there you go. So that's one intersection done for the AM peak hour, right? So you have your intersection name, your movements, and your LOS letters would be right here. So this is unsignalized. So 10.57 seconds is actually B. So, right, oops. So you go B, that's B. Then you got A all the way down. That's basically it. And then you could take this information and put it into a nice summary table in like a technical memo or something. So if you guys just want to do that for your AM node, just get it done. Does anybody have any questions on how to do that for the node spreadsheet?
So
I do actually have a question, sorry.
Yeah, go ahead.
So when you're copying down that yellow column there, did you just go to the top of the average list once you hit the other ones and then just copy down the first?
That's right. So I averaged out by picking each individual cell for this first one for all the time intervals. Okay. And then I just dragged it down so it just applied that same formula because your movements will be in the same order at every single interval, right? If that makes sense.
You averaged it out. Oh, okay, I dragged. Sorry, I just copied and pasted it down. I didn't get that part.
Yeah, so when I averaged it, so what I basically did was, so this specific movement, this guy right here, I basically averaged all the delay values for that specific movement. So you can see
down to there.
So the first interval is 300 to 600 seconds. Yeah. So this is the cell. It's unfortunately it's an empty cell, but that's what it is. And then you go down, and then this is the next one for the 600 to 900 second interval.
Okay.
And then you do each for each interval group, right? For that movement. Okay. Right? Because Vissim has calculated an average delay in seconds for that movement at each time interval. So now we're just averaging up each time interval.
Okay.
Right. And just to remind you guys, we're only looking at the average section of our data, right? Because what Vissim has already done for us is, so for example, for the 300 to 600 second interval, Vissim has already averaged up the delay that happens in that interval for all 10 runs. So that's those are the numbers you're looking at right now is the average of all 10 runs, right? And then we're even averaging it a step further by now averaging the delay within the all the time intervals for that movement. It's important to understand that because sometimes like delay fluctuates over time, right? I know in synchro, you're very used to looking at, you know, what is the delay in the peak hour? But in reality, even within an hour, delay fluctuates. And for simple projects like a traffic impact study where it's you don't really need to get that detailed and all you really care about is, you know, what's the average delay in that hour, that's fine. But if you're doing a project, say for the MTO, where they're looking at delay on the highway and they want to know within that peak hour, you know, when does it reach delay level of service F? And for how long does it stay at F within that hour? Right? Does it only last for 30 seconds? I mean, 30 minutes, right? Does it happen at the beginning of the peak hour or at the end of the peak hour? Is it for the entire peak hour and it actually drags on into the hour before the peak hour and the hour after the peak hour? That's questions that come up. And when those types of questions come up, that's when consultants start to navigate from synchro into Vissim, right? So I did a similar project and we'll talk about it with the Q counters where, you know, in synchro, you can say, okay, this is the 95th percentile queue or the average queue. That's fine. But we had a project where we were looking at reducing a lane on a freeway in Northern Ontario because of road work. And they were asking us, what's the queuing going to be like? And we were thinking, oh, okay, maybe we could run this in some traffic to find out. But then they also asked us, but they asked us then, how long is that queue? Like in long, I mean time. What's the duration of that queue? Like, is that queue going to last an hour or 2 hours or 3 hours or 4 hours? And at what point is it going to dissipate? And how quickly will it dissipate? Like, is it going to take 2 hours for the queue to go from 100 meters and gradually reduce back down to 20 meters? Or will it be very quickly and it only spikes at a very short amount of time? They have all these questions, and that's when you start getting into Vissim because you start breaking things down into intervals and you're actually interested in looking at what is the operations at this specific interval and what is the operations at this specific time interval. And if for a specific operation, like a high delay, for how many intervals does that last? So you start breaking it right down. Okay, so I'll just give a few more minutes for you guys. You guys can do your AM node. Feel free to move on to the PM node as well. You know what, I'm gonna do it right now. And I'll do it kind of slowly so you guys can watch and you see if there's anything you missed. So I'm in the PM node.
Hey, Adam, when you're copying the first, is just the 300 to 600?
Yes.
Okay.
Yeah.
Adam, did you assign the movement for everything you copied, or like eastbound through whatever? Like how many of those we need to do?
I like, you mean naming the movements like this?
Did
Like
you hear
this?
me, Adam?
Yeah, I can hear you. Can you hear me?
No.
Can anybody else hear me?
Yeah.
Okay, so you can hear me now. You know what, I think you're cutting in and out.
Yes. My connection is really bad today.
Okay. I haven't listed all the movements like this for every intersection yet. Like, you know, I can do that after, or you guys can do that after. It's up to you. You know, it's better to do it. I'll probably do it after I'm done teaching. Okay, so I'm just going to do the PM node. So I'm just going to delete everything below average. Then I'm also going to hide all my runs except for the average. And then I'm just going to not stop delay. Oh, vehicle delay row. I'm going to highlight in yellow just to make my life easier. Oh yeah, and then up at the top, I'm going to copy the names of all the movements. That's them right there. And then I'm going to go down to the bottom, paste it. And then right here for the first movement, do the average formula. And then using the control button, holding the control button when I click, I'm going to click for the first movement. And that's it. Close bracket, enter. And now I can just drag her down. There we go. And that's really it. And again, I can clean this up after by actually inputting the LOS letters and by actually naming the intersection here and naming the individual movements here by looking at my Vissim model. And again, you can do that at the end of class. You can do it on your own time. It's up to you. It's not something that I don't need to assist you with that.
Hey, Adam, quick question for you.
Sure.
Are you recording this and posting this online?
I'm not recording this right now because it'll be a massive file, but I'll record myself doing the node and then doing the queue after, and
Okay.
I'll post that. And I'll do it. I'll do it quick for the recording, and then you can just pause the recording whenever you need to.
Okay, perfect. Thank you.
No problem. Somebody also asked about a pivot table. I know, like, there's different ways you can do this. You can use a pivot table to help you with this stuff. For me, sometimes like I just like quick and dirty like this, because maybe I don't want to waste time doing the pivot table. But to be honest, if you look at the long term, if I developed a really good spreadsheet for this, then I could just reuse that spreadsheet every time I did Vissim analysis. You're right, that'd be a lot better. I think this is just the method that I did, like the raw basic way of doing it, and then I just kept doing it this way. So.
Hi Adam, just wonder about node 3. So we have just 3 and no link, no connection. So what is that? We have 3, 1, 2, 3, 4, 5, 6, 7, 8. You see the only 3, the blank.
Some are blank, right?
Yeah, no, go down more.
C.
2 more, 3 more.
Column C.
Yeah, column C.
Oh, column C.
Yeah, and you see number.
Oh, this.
Yeah.
It's, you know what it is? It's just it's like a summary. Like here, let me show you. It's just a summary. Like number 6. Like this is intersection 6.
Yeah.
And this is 6. And this is. Let me just confirm. I don't think it's the average of all movements. Let me just check. Oh, it is. They are averaging. Okay, so it's essentially just the average of all the movements, of all the values above for that intersection, right?
So if we take all the number 6, so we have the average already. for.
But these are different movements, right?
Uh,
So it's kind of useless. Like, you know what I mean?
it's the average for that node.
But it is, but that's useless because you want to look at your node on a movement by movement basis, right? You don't want to average all the delays for all individual movements.
Okay. I see. Thank you.
Like you can, but I'm just saying I don't think that would be useful. And
Mhm.
that's something too that just my recommendation for any of you that get into using synchro a lot when you start working and things like that. I'm not a huge fan of quoting what the overall intersection delay is. And to be honest, even the VC ratio makes a little more sense to me looking at what's the overall VC ratio of an intersection. But in reality, it's not that very helpful in my opinion, because you have multiple movements and you should be looking at movements on an individual basis. To say that the LOS of the intersection is C, it doesn't mean anything because people don't drive all the movements. They drive only one movement. And if you want to identify are there problem movements at that intersection, you need to look at individual movements, right? So that's more what I care about, to be honest. And you should get in that habit. You know, it doesn't help to say, oh, the VC ratio at this intersection is 0.75. Okay, that's like a good high level indicator that there is some reserve capacity at the intersection, but is there a specific movement that's just being destroyed? You know what I mean? That has like 0.99, and then you have a lot of other movements that are working great, and it's skewing it, and it's just not telling the story, right? So it's just my 2 cents, to be honest.
And which the one without value? So you see the arrow divided by 0. So that is mean that there's no delay on that link.
You know, you have to look because again, sometimes there's no movement here, and let me just see this as an example. So this first one, I'm getting a 0, and this is 6 Bimbrook Road to 5 Bimbrook Road. I know this is at my roundabout. So if I go to 6 Bimbrook Road, 1 second. What am I doing? Why am I not? That's 10. Yeah, so this is 6 Bimbrook Road. See, watch, it's gonna. Where's 5? 1 second. Go to my show list. 6 Bimbrook Road. 5. Yeah, so it's the U-turn. That's what it is. So I believe we have not assigned any U-turn volumes to our network. So there's 0. So it is LOSA, right? There's 0 volumes, but that's the U-turn movement. So that's 0. This one is probably the same. This is probably 8 to 9. I bet you that's a U-turn. 8 to 9. Yep, that's a U-turn. And then this one is 12 to 13. It's probably this one. 12 to 13. That's the U-turn. And then this one's probably the last one. So this is actually giving me a connector number and of 10012. You can tell that's a connector just because it gives you those long digits. And that just happens to be just the way when you drew your node line around the intersection, it just happens to be that the node line crossed the connector, like crossed over the connector and not the link. And that's fine. So it's connector 10012 to link 11. And I bet you that's this. Yeah, 10012 to link 11. And you can see, as an example, this is how the node thing is working, right? So you can see the node line, the perimeter line, is crossing over this connector and not the link. And that's fine. It doesn't matter. So it's saying going from this connector around to this exit point, recrossing the node number or the node line, right? So it recrosses the node line at link 11. So that's the movement, right? So essentially, you know, just to give you the grand scheme of things, this node line perimeter is detecting, you know, when a vehicle crosses it and then crosses it again, right? So it crossed the yellow line here, and then it crosses the yellow line over here. So that's considered a single movement, entering and exiting the node. And that's what you're getting your delay, right? Yeah. Okay. Does anybody put up your hand if you need some assistance with the node calculations? Yeah, go ahead, Brian.
Can I just share my Excel sheet, Adam?
Yeah, sure. Okay, just give it 1 second. Okay, it's up.
Okay, so I have my my first thing here, but I'm not too sure if I'm averaging this properly because this is my node 1.
Yeah.
Two, 3, 4, 5, 6, 7.
Yeah.
Okay, so that's for run 1.
Mm-hmm.
300 to 600 up to this point here.
Yeah.
This point, sorry.
Yeah. Yeah.
Right. So when I'm doing the average, I'm pulling it for
That
this
one.
this row. So I think, hold on. This one, and then I would pull for this one.
That's right. Yes.
6 of 900.
Yeah.
And then I'll go 9 of 1200.
Yeah, that's right.
Right up to
The 3600 to 3900 would be your last one. So let me see which one you clicked. Oh, wait. Oh, I think you went too far. Oh. Oh, you know what? You should. Oh, you know what? You forgot to hide. You know what? No, you're only averaging the average rows. So you see the first column has the number 1 in it.
yes.
That's the simulation run. You're gonna hide all the rows for simulations 1 through 10. And the only rows that you're gonna have left showing are the ones that start with AVG for average.
Oh, okay.
I think you just skipped that step, and that's what's screwing you up.
So I should have hit.
Keep going down. So you're gonna, so and then you're only gonna have the average shown. So just hide all rows that start with 1 to 10.
So all these come above. Hide.
That's right. You're gonna hide them all,
Okay.
except for the row headers, and except for the first row in the whole spreadsheet.
Okay. And then I would do the average.
And then you do the average, do the same thing you just did, but only for the average stuff. Yeah.
Okay. Now I understand. Thank you.
Yeah, no problem. Okay, does anybody else have any questions regarding the node calculations? Okay. Okay, so let's do Q. So this is a smaller, well, not smaller, it's a longer spreadsheet, but not as wide. So again, you can see we have our sim run numbers. So this is simulation 1.
Adam, we cannot see your screen.
Thank you. Okay, so simulation 1, and then we have the time intervals. And then what we have here is Q counter. So these are Q counter numbers. So you can see I have 3 to 28, and then again 3 to 28, and it just keeps repeating. So those are my Q counter numbers. Your Q length, so that's actually your average Q length. That's what that means, is the average Q length. So for Q counter number 3, within this 300 second window, from the 300th second to the 600th second, the average Q length was 0.65 meters. The maximum Q length was 11 meters, and it recorded or observed or whatever 10 stops. They're called Q stops, whatever that number means. It's not very useful. So we need to calculate, well, what we should calculate is the 95th percentile Q and the 50th percentile Q. And I'll show you how to do it. So again, you want to delete the first row because it's useless. And then we're going to delete all the bottom sections. So we have simulations 1 through 10, but we're going to delete everything including average. Just going to delete it all. We don't need it. And now we're just gonna sort it to make our life easier. So what you're just gonna do is you're going to press sort and filter, custom sort, and it should highlight the table on its own, but not the headers. And I would recommend first sorting by Q counter. And then we're gonna add a level, and then I would sort by sim run.
Adam?
Yes.
Which button you click
Yep.
to create the
See up
sort?
here, sort
Yeah.
and filter, you click that. And then it's a drop down, and then you press custom sort.
Okay.
And then this should pop up. So then I do sort by Q counter, and then sort by sim run. So you see this one, it ends with sim run. So if I assume a lot of you are following along maybe, so I'll just go a little slower, okay? So like I said, delete the first row that has that title, then delete all that bottom rows, that average, the min, the max, standard deviation, all that. So then all you're left with is your sim runs 1 through 10. And then you're gonna click sort and filter, and then you're gonna go to custom sort and sort by Q counter, and then sim run, which is this one right here. It says Q counter evaluations sim run. Press OK. So now it's cleaned it up a bit. So now you can see we're just looking at Q counter number 3. So you look at one Q counter at a time. So it's a little cleaner. And you can see as we go down, so this is Q counter 3, and then it goes through each time interval for Q counter number 3. And then it resets to the time intervals again because now we're in the second run. And then you go to the third run. And then you go down to the fourth run, all the way to 10. So what I would do for you, I would look at each sim run. So here's sim run 1, right? That's sim run number 1. So what I would do is like right here, well, let me make a header. I'm gonna call it 95th. So we look at the 95th percentile Q for each sim run. So I'm gonna say, I'm just gonna say sim runs. And then I'm gonna say 50th sim runs. You'll see what I'm doing in a second, just one sec, okay. 50th is good because it's the average Q, right? 95th is good as well because that's what we designed for. So those are 2 good values to have. So right here, which is kind of the bottom of sim run 1, because you can see now below that line, we transition into sim run 2. So right here, I'm just going to do the average. Sorry, I'm actually going to calculate the percentile. So if you go to equals, you go to percentile, and I go to the bottom one. Well, I don't know if it's bottom for you, but whatever, the percentile. And then it's asking me what array. So we are going to pick the Q length max. Yes, I'll explain why in a second. And then you press comma, and then for K, the K value, I'm going to do 0.95. And then for 50th, what I will do is drag it over. Oops. Click here, drag it over. I'm just going to drag the array back to Q length max. And for the K value, it's going to be 50 instead of 95. The reason I did this, it's a little hard to grasp, but if you really think about it, it makes sense, is when somebody says to you, what's the 95th percentile Q over the 1 hour period? And you've broken it up into intervals. You're not taking the average or the max of each. Well, you are taking the max, but you're taking the 95th of all of them, right? So basically what you do is you look at so if somebody says, what is the Q in this time window? What is the Q in this one? What is the Q in this one? When they say what is the Q, well, the Q is always moving. The Q is never one number. So it's really what they're saying is what is the max Q? Like what is the Q reach? Right? That's okay. That's the better term. So you're saying within this time interval, 300 to 600 seconds, what's the Q reach? The end of Q. Well, that's the Q max, right? So at this time interval, the Q reaches that. At this time interval, the Q reaches that. So these are the different lengths of the Q at the time intervals. And then what we want to find is, okay, so looking at that, what's the 95th percentile? Meaning, out of all these queuing events, what's the 95th percentile? Which is, what is the queue length that is not exceeded 95% of the time based on this? And that's your 95th. You take your 95th of all your Q max. And then your 50th is the same. So 50th percentile is another way of saying average. But we're not finding what's the average of the average. You're finding what's the average of the max, right? So you look at your peak hour in all these time intervals, and you say, okay, in the first time interval, the Q reached 11 meters. In the second interval, the Q reached 6 meters. The average is the average of those two, right? It's not the average of the average column. That's the average of the average. That's going to give you like a lot lower number, right? It's kind of hard to grasp your mind about it, but you know, if you were to say to somebody, what's the average Q over the hour for a specific movement? What they're really asking you is what's the average of that back of Q? So if you looked at that back of Q, where is it always ending up? Well, that's your Q max, right? So they're not asking you what's the average of the average. So I'm just going to stop saying that. Okay, so that's that. And then what you can do is you can repeat that like this. So let me just think there's a quick way to do this. 1 second. Yeah, so we're going to copy this and we're going to paste it for each sim run for this Q counter number 3. So now at the bottom of number 2, paste. Bottom of number 3, paste. Number 4, paste. Number 5, paste. Oops. Number 6, paste. 7, paste. 8, paste. And 10. Okay. So those are your 95th and 50th queues for each of the 10 simulation runs for this queue counter. And now you want to find the average of all those simulation runs. So now I'm going to write up here 95th, and I'm just going to write all runs, and 50th, all runs. And all I'm going to do is all the way at the bottom here, I'm going to get the average. Just to make it quick, this row all the way to there. And then then I drag it over. What's the average of the 50ths? That's it. So this right here, and what you could do is highlight this yellow so you can find it quickly later. So basically for Q counter number 3, the 95th percentile Q is 19.23 meters. The 50th percentile or average Q is 11.6 meters, right? And then to quickly repeat this process, I would just highlight this whole section of what you've just done, copy, and paste. Let's say we got some zeros there, that's okay. Okay, that's it. And then what you can always do is make a summary list at the bottom. So if I listed all the Q counters, so I think if I look at my Vissim model, the Q counters go from number, one second, show list 3, so it's a little, let me see if I just copy this. Just gonna copy this right here. See if that works. I just put it right here. Doesn't really matter. Just 3, 5, 7, 8, 9, 10, 11, 28. Yeah, so those are my Q counter numbers. And then what you can just do is you can do something like, I think this is how I've done it before. So just there is a way to make a summary table of all that information above, but yeah, there's got to be an easier way. One second. I don't know. I can't really think off the top of my head, but if somebody else knows of a quicker way to make a summary table at the bottom, there is a way to do it.
Adam, so we calculate the 95th percentile of each count, right?
Each Q counter, you should calculate a 95th and a 50th.
And for each run, right?
Yes, and then you're going to average all the runs.
and then average all the runs. So let's say we have 10 runs, 10 runs, and we have 25 count, right?
Mm-hmm.
So we had to, so it means 10 and 25, it means 250. I see.
Yeah, but it doesn't take that long. Like if you see what I'm doing right now, it's going pretty quick.
Okay.
Right. There is ways if you use pivot tables and things like that, but you know, typically what you would do is you'd spend like a whole day doing this. You know what I mean? Like if you really wanted to make it look good and do it right, you'd spend a whole day and build your spreadsheet nicely. We just don't have time. So for me to kind of do it in an hour, we're just kind of quickly doing it rough, right?
Adam?
Yeah.
So I don't have the streets names like you for the nodes.
Okay. Now is that like I don't have
Yes.
the street names for all of mine. Like I just kind of some of them I do, depending if I gave them street names in my Vissim model.
Oh, I don't remember. How did we give them names?
It
Like-
would have been in the list, like show list for the links.
Okay.
That's where you could enter names.
Okay. Okay, thanks.
Yeah, no problem.
Hey, Adam, for those queue counters, how come you have different numbers for them? 3, 5, 6, 7.
It could have just been when I was drawing the putting the queue counters in my Vissim model. Maybe I did 2 of them and then I deleted them and then kept the third. You know what I mean? So
you pulled that column from your Vissim model?
yeah. So my Vissim model has my queue counters. If I go to queue counters right here, show list, you can see the numbers are listed here.
Okay,
What I just did is I just copied this into my
Okay.
Excel, so I had my list. But yeah, the reason you're missing numbers is because when you, as you're inserting queue counters into your Vissim model, it's assigning a number to each one. But then if you delete one, then you've lost that number, but it's not going to renumber all your queue counters, right?
Okay.
Yeah.
Just a question, Adam.
Yeah, sure.
I was just wondering, is this all that we're doing for today?
This is it, man. So if you've got it figured out, you know, you're free to go. And you know what, let me just show you guys, let me just pop up a project that I did for work and I'll show you what my summary table looked like in my report for Vissim I did for a roundabout. 1 second. But yeah, to answer your question, that's it. Let me just pull it up 1 second. So just to show you guys, this is a project I was working on recently where it also included some Vissim modeling for 2 potential roundabout locations. So it was 2 intersections that I did Vissim modeling for, and I did the analysis, and then I typed up this report, and I compared it to the current signal operation, which I analyzed in Synchro. So you can see I have my Synchro tables here. Pretty standard stuff. And then just 1 second. Roundabout simulations. You can see just a very basic Vissim model I did. If I zoom in a bit, you can see this is my 2 roundabouts I did. They were 2-lane roundabouts, right? And then here's the delay results. It's kind of broken into 2 pages, unfortunately, but you can see I have a scenario, my leg, movements left through right, LOS letter, seconds of delay, right? Then I have different scenarios. Then I have that information. And then my queuing results. I did queuing in a separate table. And then, so each approach, and then the 95th and the average queue. Typically for me, when the queue is less than 7 meters, I like to just say it's less than 1 vehicle, right? I don't like to put down queue of 1 meter because there's no such thing. You can't have a queue of 1 meter. So that's why I like to put less than 1 vehicle when it's below 7 meters. So just to give you guys an example, what it would look like. So you would transfer your Excel data. Some people like to make the table right in Excel look really nice. Personally, I like to make the table in Word and then just hand transfer the numbers from Excel into Word. And that's just the way I've always done it. It's a little more time consuming because you're doing it by hand, like just hand bombing the numbers from Excel into Word. But I consider that my own level of QA. Like what I mean by is like quality control. Like at work, we call it quality assurance, where everything you should review all your work. So when I'm actually manually transferring my either Synchro results from the Synchro report or Vissim results from Excel into the Word document table, that's like my opportunity to read through all the results and to it helps me notice if there's a major issue with something. So just some food for thought. So let me just finish up my table here, almost done. Okay. So I've got all my 95th, and then I'm just going to drag it over to get my 50ths. That's it. Let me just separate this a bit. And then you could also round it. So you can add your round formula in there. You can do like a true round, like round it right to 0. If you want, you can round up, you can round down. Everybody has different preferences. Not to enter it. Nah, I'm not going to do it there. Anyways, what you can do is you can round it over here in a separate table, right? So you can go. And there, that's it, rounded. Oops. These are all the Q counters. This is rounded. Okay. And that's it. And then, yeah, like I said, like you did for the node tab, you can look in your Vissim model, find what this Q number means, and you can give it a movement. So like I know Q, it's Q3, number 3. Oops, wrong button, of course. So then what I would do is I'd go to my Q counters. Here it is. I click on this. It's going to highlight. It's a little hard to see when you have a bigger network where it highlighted, but if I click on it again, oh, there it is. It's up here. So that's Q counter number 3. So then I know that's southbound through. So you can do something like southbound through, then you would write street A at street B, whatever the intersection is, something like that. You can clean up your table, make it look proper, but that's how you would do it. And then you'd be looking at these rounded Q values. You can see we have some crazy one right here, 191 meters. So the average Q is 100 meters. It's quite long for average. So if we find that at Q counter number 16, it's probably at the signalized intersection. So if I find Q counter 16 on my list here, oops, right here, bet it's at the, yeah, it's that northbound through right. Yeah, personally, I don't think the signal timing plans are the best. That's why we're getting some high queuing. But it's strange, you get a high Q of 100 meters. The average Q is 100 meters, it's gonna be like back to here. The 95th could potentially go all the way back to here somewhere. But if you look at the delay, AM node, so that is that's node number 6. So southbound through, southbound right, so 1 second. Node 6, all the delays. Oh, look, there it is. That's it. Movement 31 to movement 26. So if I see 31, 1 second. Oh, that's doing that. Southbound left. Southbound left. (31 to 26), 391 seconds. Yeah, is that the right one? So 391 seconds southbound left. But the delay, that's Q counter number 22. So Q counter number 22, yeah, it's still long. Not too long, 50 meters is the 50th, 100 meters, 95th. Okay, that's it. I'm teaching for today. Again, you can spend time today cleaning up your spreadsheets to give them proper headers and all that. It's up to you. I would clean them up if I were you. And then, for assignment 2, you're essentially going to submit your Vissim file. You're also going to submit your Excel spreadsheet. And let me see if there's anything else I said in the outline what you're going to submit. No, I didn't specify. Just Vissim model. So you're just going to submit your Vissim model and the Excel spreadsheet when assignment 2 is due. The final project will be the Vissim model, the Excel spreadsheet, as well as the technical memo. So if anyone has any other questions.
Can you show me, sorry.
I just have a quick question. So for assignment 2, we're not doing the roundabout at that S bend, right? That's only for the final project?
That's right.
Okay, so then when we're doing, so essentially for assignment 2, we're doing the Excel, and then for the final project, we're doing the Excel part again, right? So we're doing it twice?
That's right. So for the final, for assignment 2 is basically everything you've done up to tonight, right? For the whole Bimbrook Road, not including the S-Bend stuff, but everything for this Bimbrook Road section in downtown Bimbrook, everything.
Okay.
For final project is purely just the S-Bend. So the Vissim, the Excel, and the memo.
Okay, perfect. Thank you.
Yeah, no problem.
Excuse me, Adam, can you show me the short criteria? Can you show it again?
The short criteria, the what?
Yeah.
You know what? I don't understand. What is that?
The short, your short function where you put the criteria, the first and the second. So which one is the first? We got.
Oh, for the Q tab?
Yeah.
You know what? I'm still not following. Sorry, the first and the second.
How can you arrange the data? So which one first? Which one second?
Okay, so.
Yeah.
Sorry. Okay, the sort and filter. Sorry.
Sort and filter.
Yeah, my bad. So yeah, so for the queue. Yep. Sorry. Custom sort.
Okay.
Oops. 1 second. Let me just click up here. 1 second. Yeah. So it should highlight your table automatically.
Yeah.
And then you're just gonna do. It should look like this. So you're gonna put queue counter, right? And then you're gonna press add level, and then the next level it's gonna be queue counter evaluation simrun. And then everything else should stay the same. Cell values, smallest to largest for both. Yeah, okay. I can't do it again because I've merged some cells, but that's it.
Oh, thank you.
No problem.